Assalamualaikum. In this video, I will continue to finish up the chapter 3, the oscillator. So last video, we have covered the first and second objective. So in this video, I hope I can finish up and make you understand about what we call as phase lock loop. So what is phase lock loop? It's actually provide frequency selective tuning and filtering without calls for inductors. So the application that use PLL is mostly in transmitters and also receivers, regardless either what kind of signal that you or modulation process that you're going to use, either AM, FM, PM, or using digital signal FSK, ASK, or PSK. Stereo decoding, tone detectors, and also frequency synthesis. So this is the block diagram of PLL. It has a comparator, phase comparator, to compare between the external input signal with the output of VCO, low pass filter, amplifier, and also voltage control oscillator. So it is actually a feedback loop system, all right, and we want to use the PLL to get the stable frequency, all right. For the PLL working principle, I will explain to you in the next slide, but this is the block diagram that is similar with the one that I showed previously. So the external input signal may have Fi as the input frequency, and it will pass through a low pass filter and also the amplifier to get the frequency of desired FD to be input into the voltage control oscillator, and it will we will use this natural resonance frequency from the VCO to get the output and to be used in phase comparator together with the external input signal. So in the VCO, if you see over here, it's actually we need to find the frequency of output by taking the difference frequency, which is come up from the FD over here, and add to the FN, or natural resonant frequency of of VCO, right? And then the FO will be used to compare with the FI over here inside the phase comparator. So PLL, okay, this slide I don't give in my lecture notes, so you may want to jot down or write down this in your notes, your own notes. All right, but I always explain this in my class, in my lecture. So for PLL, it's actually a closed loop feedback control system with the parameter of interest are the frequency and also the phase of the signal. So it has four components, as I mentioned earlier: phase comparator, LPS, low pass filter, amplifier, and VCO. So in the phase comparator, first at initial stage, the input frequency is compared with the frequency of VCO output, or what we call as FO in the earlier slide, and then produce error voltage, sorry for the typo here, voltage VD. And then when we have the VD, we will filter and amplify the signal VD using LPF and amplifier to produce what we call as the derivation of D. Okay, and in VCO, if the input frequency is close enough to natural resonant frequency of VCO, it will lock the PLL will sync or lock on external input signal, and the VCO output is the difference between the input frequency and also the FN, the natural resonant frequency of the VCO. So what happened basically in the PLL is actually we can divide into three operating states. So the first state is the free running. Okay, free running is where we don't have any input signal into the system, and it will be the open feedback loop for the PLL. And then the capture state, once the system has an input signal, it will have the input frequency. So it will complete the feedback loop of PLL, and it will start the process of occurring frequency lock. And lastly, the lock state, once we have the input signal into the system, the VCO output frequency, FO, will be same as frequency of input, and then whatever the frequency input has, the FO will track or follow any changes that frequency input get whenever the what call it whatever signal they inject into the phase comparator. Alright, so this one will be done in phase comparator. Alright, comparator. So this is the three operating states that you must know in a PLL. Right, and when we have learned about the operating state, that means we have free running, capture state, and lock state. In the capture state, we have what we call as capture range. All right, and this capture range is actually defined as the band of frequency in the center of natural frequency of VCO. So when we have this, the PLL can establish and acquire lock with an input signal. So the pull-in range is basically the half of the capture range. And this is the spectrum of the frequency that cover but under capture range. So the capture range basically is the 2 times carrier frequency. All right, and half of that will be the pull-in range. And it must be calculated or defined based on the FN, the natural frequency of VCO. So this will be the center of the capture range, the center, and the range of the capture range will be the twice of carrier frequency with the VCO FN at the center. All right, and we can have it as upper capture limit or lower capture limit. Right, next is the lock range. The lock range is defined as the range of frequency at the center of the VCO natural frequency Fn, and which the PLL can maintain lock with an input signal. So for this one, we call it as holding range. This holding range is the half of the lock range that is which I will explain it from here. Alright, so this is the lock range with the center of VCO natural frequency. Alright, so the lock range basically is the frequency of twice of lock frequency, and it will whenever the system or PLL is actually in this range, the PLL will be in the lock state until it come out from this range and be in the what call it need to be capture state or lock state again. So this is the difference between lock range and also capture range. If you see over here, the frequency range of lock range is wider rather than capture range. So we need to capture first in in the narrow range of frequency before we can have it in the lock state. And in the lock state, the PLL will consider the frequency or the VCO to follow whatever input signal or input frequency has within the lock range. And if the frequency is out of lock range, so the PLL will go back to the capture range and capture state, and then get the lock state again until it comes out with a stable frequency. Right, so this is the characteristic of VCO. So basically the FO, the output of VCO is equal to natural frequency of VCO that is determined by external RC network. All right. And for the phase comparator, the input-output relation basically will be opposite. All right, the opposite voltage occur for opposite direction of phase error. So the slope is positive for this part. All right, and the output voltage versus phase difference for square wave inputs is when Fn is equal to Fo and lock onto input signal with negative 90-degree phase difference. Right. This is the example or one way how we can use a PLL inside our system. You may use this IC with model number XR215, 16 pins. All right. And this IC basically well suited for FM or FSK demodulation process, frequency synthesis, and also tracking filter application. And the range of the frequency for this IC PLL is ICPI is between 0.5 Hz to 35 megahertz, and it can accommodate analog input voltage between 300 microvolt up to 3 volt. So inside this IC, we have all components of PLL inside it. We have VCO, we have phase comparator, and also the amplifier. We just don't have the LPF, low pass filter inside this, but it always can be connected outside when we have uh, tune the cut-off frequency for the system. All right. So I think that's it for chapter 3. Maybe you can proceed to chapter 4 and understand better. And of course, do not forget to do the exercises, the tutorial questions, and also the chapter review for your assessment. Okay. Thank you for listening. Assalamualaikum.